So, your introductory circuits professor probably told you that you can't turn off dependent sources when using the superposition method. My name is Aaron Lanterman. I'm a professor of electrical and computer engineering at Georgia Tech, and I'm here to tell you that your professor was wrong. I'm not picking on your professor in particular because most professors get this wrong. I think largely because most textbooks get this wrong, at least every textbook that I've seen. My colleague Marshall Leach discovered this subtle yet powerful method of performing superposition, including the deactivation of dependent sources, and I'll do an example here. Okay, so let's do practice problem 4.7 from page 138 of the third edition of Alexander and Siddiqui. So in this problem, we have a 4 amp source, and this is very much a textbook sort of problem. 4 amps is a terrifying amount of current. And we have a 10 ohm resistor, we have a 5 ohm resistor, and then we have a controlled voltage source. And notice the way the sign on this voltage source is set. And the voltage here is controlled by a current Ix, and the current Ix is measured flowing down this direction. So the problem asks us to find Ix using source transformation. Here we're going to find Ix using Marshall Leach's superposition method. So first I'm going to redraw the circuit using just the 4 amp source. So I'll have 10 ohms here, and then I'll have 5 ohms here. And when we deactivate the controlled source here, it turns into a short, and so it just looks like this. So to find out what the current flowing down here Ix is, I can use a current divider. So Ix is going to equal 4 amp, and then I have 15 in the denominator here. It's the sum of these. And I tend to use voltage division more than current division, so I usually mess this up. When you use a current division technique, you want to include the resistor that the current's not flowing down as what you put in the numerator. All right, so this is just going to be 4/3 amp. Now, what I'm going to do here, I'm going to put a little superscript 1 to remind me that this is the current associated with this particular part of the circuit. All right, so let's look at circuit 2 here. Now what I'm going to do is I'm going to deactivate the independent source, so this turns into an open circuit. And now I have my controlled source here, which is 2Ix. I have 5 ohm, 10 ohm, and then I have the current here, Ix. And again, this is what the textbooks tell you you shouldn't do. Okay, now by Ohm's law, Ix is going to equal minus, because I have a minus sign up here in my controlled voltage source, 2Ix. That's a voltage, and now I need to divide it by the resistance here to get the current, which is going to be 15 ohms. Now, I'm going to be extremely careful here. I'm going to put a 2 here, but I'm not going to put a superscript 2 over here, because you can't solve for the controlling variable using Marshall's technique until you've included all of the contributions. So this isn't something that Marshall does in his papers on the topic. I like to do it because it helps me keep track of things. All right, so now what is Ix? Ix is the sum of these contributions. That's going to be Ix1 plus Ix2. Let's see, Ix1 is 4/3, and then Ix2 is minus Ix2 over 15. So let's see, if I move this Ix2 over 15 term over to the other side, it's something like Ix17 over 15. And then I'll have 4/3 on the right. So Ix is equal to 15 over 3, which would be 5. And then I divide by 17. So I would have 20 over 17. And this is in amps. And this matches the solution given in Alexander and Siddiqui that they achieve using source transformation. The mistake people make is they'll look at this and they'll think, well, if I look at this circuit, Ix must equal 0. But the mistake they're making is they're trying to find Ix before they've included all of the contributions.